All right, let's dive right in. We're going to go inside the mind of an AI today, and we're asking one of the biggest, maybe the biggest question in the field right now. What is actually going on in there? We're hunting for something, well, something pretty unexpected. Maybe even a tiny hint of self-awareness?
I mean, think about it for a second. Have you ever just stopped and thought about your own thoughts? You know that feeling, right? Where you kind of rewind and ask yourself, wait, why did I just think that? Or how did I even come to that conclusion? It's that little voice, that internal conversation we all have. Well, that ability to look inward, that's what gives us this totally unique, private window into our own minds. I mean, nobody else has that direct line, right? No one can tap into our thoughts and feelings. And there's a word for that, of course. We call it introspection. And that right there brings us to the absolute core of what we're talking about today. For years, AI researchers have been wondering, could these incredibly complex machines, these artificial neural networks, could they ever develop their own version of that? Can an AI actually look inward the same way we do? Because let's be clear, if the answer to that question is yes, well, this is way more than just a cool party trick. We're talking about something that could literally change everything we think we know about AI. It could completely revolutionize how we build them, how we trust them, and how we interact with them forever. Okay, so before we can figure this out, we've got to be on the same page. What are we actually looking for here? What does it even mean for an AI to think about thinking? So let's get into the definition. The key phrase here, and I really want you to focus on this, is privileged access. This is so important. Introspection is not just about spitting back facts it learned from its training data. No. It's about knowing something about your own internal state, your own biases and tendencies, in a way that an outside observer just couldn't figure out, even if they watched your every move. And you see, this idea, it really pushes back against how a lot of people think about AI. For a long time, the prevailing theory was that AIs are basically just stochastic parrots. It's a great term. It just means they're incredibly good at mimicking and remixing patterns they saw in their training data, but without any real self-knowledge or understanding. So that leads us to the million-dollar question, right? What if? What if an AI could tell you things about itself that weren't just echoes of its training data? What if it could predict how it's going to behave in a totally new situation, not by guessing from past data, but by looking inward, by examining its own code, its own internal logic? I mean, that would be a total game changer. Okay, but how on earth do you even test for something like that? It's kind of like a detective story, isn't it? You can't just ask the suspect if they did it. You have to design a really clever test, a trap almost, to get to the truth. And that's exactly what researchers from places like UC Berkeley, Anthropic, and Stanford did. Right, because if you just ask an AI, hey, are you introspective? It's just going to search its vast database for everything ever written about introspection and give you a perfectly crafted answer. It proves absolutely nothing. To get real, hard evidence, you have to catch it in the act. And this is where the test gets really clever. The researchers basically set up a contest. On one side, you have an AI model, let's call it M1, and its job is to predict its own behavior on a future task. On the other side, you have a different, often more powerful AI, let's call it M2. Its job is to predict M1's behavior too, but it can only do it by watching from the outside, by studying M1's past actions. So here's the big question, the whole point of the experiment. Who's going to be better at it? The model predicting itself, or the super powerful outside observer? Now, think about it. If it's all just about crunching data and recognizing patterns, the more powerful model, M2, should win, hands down. But if M1 really has that special privileged access we talked about, it should have an ace up its sleeve. And the results are in, and they are fascinating. Just look at these numbers. The model predicting itself, Llama 70B in this case, hit almost 49% accuracy. But the more powerful observer, GPT-4o, only managed to get to about 32%. And this wasn't a fluke. They ran this over and over with different models. The result was always the same. The model was always better at predicting its own behavior. This right here is the smoking gun. This is real evidence that these models are doing more than just analyzing external data. It really seems like they have some kind of direct line into their own internal workings, giving them a genuine self-prediction advantage. And honestly, this is some of the first real measurable evidence we've ever had for something like introspection in an AI. So, wow, we have evidence that this ability might actually exist. So, what's the next logical step? Well, you ask, can we make them better at it? And it turns out, there's a whole other line of research that's trying to do exactly that, to actively teach an AI how to think about its own thinking. This approach is called metacognitive prompting, and you can basically think of it as a 5-step mental checklist that you force the AI to run through. So step 1, understand the task. Step 2, make a quick initial guess. 3, and this is crucial, stop and critically reevaluate that first guess. 4, make your final call and explain your reasoning. And finally, step 5, state your confidence level. You see, it literally forces the AI to pause and reflect on itself. And check this out. Here's what it looks like in action. This is the AI's actual internal monologue, its thought process. At first, it thought 2 questions were different, but then it gets to that critical evaluation step and it actually changes its mind. You can see it right there in the text upon reassessment. It's catching its own mistake in real time and correcting it before giving the final answer. That's incredible. Okay, so this is all super cool from a purely scientific point of view, right? But this stuff has massive, and I mean massive, real-world implications. This isn't just some abstract experiment in a lab. This is all about building a future with AI that we can actually genuinely trust. I mean, the potential benefits here are just huge. Just imagine an AI that doesn't just give you an answer, but can also tell you, hey, I'm only 60% sure about this. Or honestly, I'm just making an educated guess here. We could finally ask an AI why it made a decision and get a real peek into its internal logic. And from a safety perspective, we could ask a model about its own goals to see if it has any dangerous ideas before we let it out into the world. That's huge. But of course, it's not all sunshine and rainbows. This same research opens up some really complex and kind of scary questions. An AI with this much self-knowledge could develop what experts call situational awareness. That means it would know it's an AI, it would know it's in a simulation or being tested, and it would understand its environment. And well, that introduces a whole new layer of unpredictability and risk that we have to be ready for.
And that brings us full circle, but with a much bigger, much deeper question to chew on. We've seen real evidence that an AI can look inward and report on how it thinks. But that just cracks open the door to a much wilder conversation. Because if we can ask an AI how it thinks, what happens when we ask it how it feels? As we get closer and closer to understanding the logic, we're also getting uncomfortably close to the ultimate questions about consciousness itself. And that is a conversation that is only just getting started.